The next question in our Java interview series is write a Java method to check if a given string is a palindrome or not. So this is coming from the data structure. We have to give the logic, how many approaches there are that we can solve to see if given input string is a palindrome or not, that we are going to understand in this video. Apart from these one, I am going to explain you all the related questions, like we are going to read out all these one. That will solidify our understanding about this program and the related questions as well. So let's go ahead and see the first thing, that is, let's say if this is the input string, let's say A, B, C, B, A. If I read it in the forward direction or if I read it in the reverse direction, A, B, C, B, A. If I go from in here A, B, C, B, A. So if I go in forward or I go in reverse, I should get the same string from there, right? So input will be this one and the output should be whether just the method will have that logic to check if this is a palindrome or not. Based on that, it will return true, false. So there are three approaches that can be used to solve this one. This is very easy problem. So two pointer approach is there, that is the first one. Second one is the reverse string and third one is the recursion. So let's see one by one. So how two pointer approach will work. So given a string, so I will just write that down. So we have this A, B, C, B, A, right? So this is the input. Okay, so what we can do, we can take two pointers, right? So let's say A and let's say this is a B. So I will start a for loop from here. I will compare the first one. So I will say compare this and this. If they are same, I will move next. Next means the left side pointer I will forward it and the last pointer I will reverse it. So I will be reaching at the second character and from the second last here I will compare both of these. If they are equal, that means we are in good shape and the string is possibly a palindrome, right? So we'll move it from here further, we'll increment it further and we'll decrement this one side. So we'll come to the next character, that is C, which is again equal, right? So we are still we are again in a good position and have positive vibe that this is going to be the palindrome. So we'll again forward it plus and minus. At this point, this is going to be our terminating condition where A less than B, where A greater than or equal to or equal, where A greater than B. Basically we can say when this crosses this one and this one, so we can say that is the terminating condition. And this way, if we have reached to this condition, that means output is true. At any point in time in here, if there is comparison is failing, so we can just come out of the loop and that will go as a false. Okay, so what is the time complexity of this one? Time complexity is going to be the order of n. What is going to be the space complexity? Whatever length we have, like whatever string length this is going to be there, we are going to be in the same loop and the same piece of code. There is no extra memory for this one for the processing. So that space that it is going to take is the order of 1. So that is the two pointer approach. Reverse, this is very obvious, like we had this input A, B, C, B, A, right? So we can just reverse this one, right? We can just reverse it and then I can compare both of that string, right? So this is the reverse and I can compare it, right? So if input dot equals reverse, if this is the case, I can say that this is true. Okay, in this case again, time complexity is going to be the order of n only, because it is going to compare, it is going to reverse this one basically, right? What is the space complexity? Space, this is the new variable, right? The reverse. So this is going to take the equal space, that is the length of the input one. So the space complexity will come out to be of order of n, right? So this is the reverse one. Another one is the recursion approach that we can have. So this is very similar to the first approach that we had. So what we can do recursively, so if we have this input BA, so we can have one method in here and recursively we can compare the first and last characters from in here, and the terminating condition can be like if the string length is 0 or 1, we can consider it as a true, that always palindrome. And another terminating condition is going to be that the left pointer is less than right. So the terminating condition in here is going to be not left less than right, but left this greater than right. So because whenever this pointer is going to be exceeding this one and this one will be exceeding this one, so we will see that this is the terminating. If we reach this point, that means it is a palindrome. So let's see the program execution of each of these one to solidify this understanding, this logic. So and before coming to the program, so here also this recursion is also going to have a order of n of time complexity, and space complexity is going to have the order of n also. So which one is the best approach among this one? So two pointer approach is the best one. So always present more than one approaches and choose the best option that is there. So start from the very basic one. Like here in this program is in itself very simple. The reverse string looks very simplistic to me, so start from here and reach to the two pointer approach. So let's see the program for this one and conclude this video. So here we are at IntelliJ IDEA. So let's create the class for us. So we have this package already there. So palindrome example. Okay, so this is what it is going to be there, and we will write the methods for each one. So how that method is going to be there, boolean, it is going to be written. So boolean. So first approach is there, so let's write two pointer approach, and this is going to take string as an input. Okay, so we will put null check in here. If input equals null, then we will consider this as false. Okay, another case, like let's initialize the variables. Left, it is going to be 0, and the right pointer, it is going to be input dot length, the method that we are using, so -1, and here we will then go to the loop. If left less than right, so this is the terminating condition. We will compare the characters basically. So input dot char at what, left one, right? So we will say that at any point in time, if this is not equal to the right index, what we will do, we will just return false, because there is no meaning to compare other characters, right? So we will just terminate this condition in here. If this is coming out of this one, so now the comparison part is done, correct? So now we have to change the pointer. So what we will do, left plus plus, right, and right minus minus. This will make sure that it is incrementing and decrementing. And if we come out of this one, that means all the characters are equal, whatever comparison we needed. So this turns out to be true. So just make this static so that we can call this from main method. So we are going to have this main method for testing. So sout two pointer approach for ABCBA. So let's say this is the string that we want to test with. So two pointer approach plus ABC. Okay, so this is going to be the string. So if I run this, it should what should be the output? Output should be true in this case. We got the true, right? So let's compare couple of other, like they do testing around some other things as well. So let's have some false case here, and so this is the odd length, right? So let's have some even length also, and let's have one more test where it is comparing basically it is passing null, so there should not be any null pointer. Basic validation basically. So make sure that you do consider while writing the program those validations as well. So this is true, this is false, this is true, this is false. True, 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 true. Okay, my bad. So I changed it here actually, but forgot to change in here. So this is going to be this one, and this is going to be this one. True, 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 false, true, false, true, false, true, false. Okay, so we are good. That means with this approach, first one. So let's see the second approach that we had. So here, this is also going to have a static boolean reverse string way, right? And it is going to take the input again. So in here we can just reverse it, input dot no, not this one. We can make use of a string builder class that is there. So we will take new string builder, will pass on input, correct? So and I can reverse this one, right? So reverse to string, and I can say return input dot equals reverse, and the basic validation obviously I will put this initial validation is going to be this one only. Reverse string way. If it input is for null, this will return false. It is just taking the reverse of the input string using the string builder method in here, and this is just comparing it, input dot equals reverse. So just to test this one, we will use the same conditions that we have. Just copy this right away here and two pointer and just run this one. So we will get the similar output that we got with this two pointer approach. True, false, true, false. So let's see the last approach. So these are the two approaches. I will write the third approach also, that is using recursion, and I'll write the code, and this code is going to be there in GitHub. So the links are available in description box and the comment section as well. So go ahead and check that out. So that is, so let's conclude this one. What is the best approach? So two pointer approach is the best one that we already saw. So let's see what are the other questions around it that you should basically cover around this one, right? So given, so the next comparison that you can do, given a string, find the longest palindrome substring. So any string can be given in there, so we just have to see if there is any substring that is palindrome, and among those available palindromes, which one is the longest one. So this is going to be pretty interesting, so try this out. So I will be writing the program for this one. Possibly I will, if I find this interesting, or if you want me to explain this one, just put that in comment section. I will explain this as well. Okay, so other programs you can just read this out, like given a string, check if permutation of it is a palindrome. Given a string, count how many palindromic substrings are present in it. Given a string, find the minimum number of insertions needed to make a string palindrome. So a lot of questions around palindrome, right? Write a method to check if two strings are anagrams of each other. So similar to palindrome, there is a condition of anagram also. So see the logic, we just have to implement that. Given a string, find the length of the longest substring without repeating characters. Check if one string is a rotation of another string. Implement a method to perform basic string comparison using the counts of repeated characters. For example, this one is there, basically encryption kind of thing we have to do. So all of the characters that are there, so we just have to print the count. So this will be space optimized if there are repeating characters in the input one. So given an input string, reverse the string word by word. This is also a string. This is also given an input string, basically sentence is given, so we have to reverse it word by word. Given an array of strings, group the anagrams together. Given a string containing just the characters like this, and determine if the input string is valid. We just have to compare. So these are the just follow-up question around the string and palindrome. So make sure that you practice this one. So this you will have solid understanding around it. I hope you found this useful. Very basic question around data structure. I'll see you in the next one in this series. So if you like the video, please don't forget to share this video with other friends and subscribe the channel as well. I'll see you in the next one. Till then, take care. Bye bye.